All right, one thing I should have showed you guys in the homework video, but I hadn't learned this prior to making the homework video, is that when you are looking for the least common denominator, another word for that sort of situation is least common multiple, and your calculator can actually find that for you. Not the whole part, not the part with the variable, but it can find the number for you. So if you're looking for the least common multiple or the least common denominator of two numbers, you can just hit the math button, go over to the second column, and then you can scroll down to number 8. So if I'm looking for the least common multiple of 4 and 27, pretty sure you have to multiply those together, but it's going to tell me that it's 108. If I'm looking for the least common multiple of 18 and 24, then the calculator is going to tell me that it's 72, which is definitely not multiplying those two together. If I multiply those together, that's a much larger number. So it can be helpful to use this to find the least common multiple if you want to save yourself some time. So again, that's hitting the math button, going over to number, and then you can scroll down to number 8, or you can just hit the number 8 and it will pull it up for you. All right, let's get started on this worksheet. So it says Jill can fetch a pail of water in 8 minutes. If Jack can fetch the water in 6 minutes, how long will it take them together? So we have Jill can do 1/8 of the job in 1 minute. Jack can do 1/6 of the job in 1 minute. So if Jill's doing 1/8 of the job in 1 minute and Jack is doing 1/6 of the job in 1 minute, then together they're doing how much of the job in 1 minute? Okay, so if I want to find the least common multiple or the least common denominator, I'm going to go over to number 8 and find that least common multiple for 8 and 6. It's 24. So least common denominator is 24x. So I'm going to multiply this by 24x. 1 over 8 times 24x plus 1 over 6 times 24x equals 1 over x times 24x. 24 divided by 8 is 3x. 24 divided by 6 is 4x. 24x divided by x is just 24. So here we have 7x equals 24. And then I'll divide by 7 to get x alone. So 24 divided by 7, 3.429. 3.429. So together they could fetch a pail of water in 3.429 minutes. Make sure, based on the instructions, that you are writing a sentence for your answer. All right. I remember students in the past having a hard time with number 3, specifically the part where they have to find the least common denominator, because this one is a fraction, or is not a fraction, it's a decimal. So we have Wilma can do a job in 6 days. And Fred can do a job in 4.5 days. So Wilma can do a job in 6 days. Fred can do a job in 4.5 days. Working together, how long will it take them to complete the job? So we know that it's going to be 1/6 plus 1 over 4.5 equals 1 over x. And the tricky part about this is just knowing what the least common denominator is when one of these is a fraction. So I don't know if the calculator is going to do this with a fraction, so let's try it. I'm guessing it won't. I keep saying fraction, I mean decimal. I'm pretty sure it's not going to like this with the decimal, but we will give it a shot. It did not like the decimal. Okay, so what my strategy here is going to be to use 6 And then I'm going to think of a number that 4.5 would go into a whole number. So 4.5 plus another 4.5 gets me to 9. And so 9 is the number that I would use to find my least common denominator. I'm going to use 9. And the reason is just because I know that 4.5 times 2 is 9. It's just easy to get in there. Is 18 the lowest common multiple? Is it the lowest common denominator for 4.5? Probably. Am I too worried about it? Honestly, I'm not. I just know it's going to work. If 4.5 goes into 9, then it's going to go into 18. So I'm going to use 18x. But that's my strategy for this one. Okay, so now I can multiply it by each piece. So 1 over 6 times 18x. 1 over 4.5 times 18x. 1 over x times 18x. So we've got 3x. Is that 4? 18 divided by 4.5. Yeah, 4. Is 18. So 7x is 18. And then we're just going to do 18 divided by 7. Divide by 7. Divide by 7. 2.571. So when they worked together, it took them 2.571 days. Problem number 1 was in terms of minutes. I could tell because they kept talking about minutes in the problem. This one is in terms of days. 2.571 days if they work together. Okay. In the past, number 4 is another problem that students have had a hard time with. The reason is because it says a swimming pool can be filled by one pipe in 10 hours. The drain pipe can empty the pool in 15 hours. So in all the problems we've done, we've talked about things being added together, but this doesn't really feel like things should be added together because they say if both pipes are open, so if one pipe has water coming in and the other pipe has water going out, how long is it going to take to fill the pool? And so this feels a little bit confusing. So we're going to write that we have one pipe working on filling the pool, but one pipe is working on emptying the pool at the same time. So the pipe that can fill the pool can do it in 10 hours, so that's 1/10. The pipe that can empty the pool can do it in 15 hours, so that's 1/15. Now, if they're happening at the same time, we're going to say that the pipe that is filling the pool is doing the positive thing. It is adding something. The pipe that is emptying the pool would be subtracting. And you can tell it's going at a slower rate because it doesn't do it as fast. It would take 15 hours instead of 10. So what we're going to do is we're going to see how much water is being added into the pool if you're taking, add, one step forward, 2 steps back. In this case, I guess it would be 2 steps forward, 1 step back. But if you're adding some water in and taking water out, but just not as quickly, how much water is getting into the pool in the long run is kind of what we're asking. It's like, how many hours is that taking? So I'm going to do math, go over to number, and look and see what 10 and 15 both go into. I don't need the calculator. I know it's 30, but I don't know. I learned the trick, and now I want to use it all the time. 30x. So I can multiply that by each term. So we've got 3x minus 2x equals 30. 3x minus 2x is just x. So it's going to take 30 hours to fill that pool. It's a lot of wasted water. Okay. We have, let's look at another problem. Barbie, number 7, Barbie can mow a lawn in 3 hours. If Ken helps, the lawn can be mowed in 2 hours. How long would it take Ken if he worked alone? So we've got Barbie. We've got Ken. We've got them together. So this one's phrased a little bit different because in most of these problems, the together part is what we're looking for. It's what we're solving. That is not the case in this problem. So Barbie is 3 hours. That means she can do 1/3 of the job by herself in an hour. Ken, we're not sure. Together, they can do the job in 2 hours, which means they can do 1/2 of the job in 1 hour. And so Ken can do, we're not sure how much of the job in 1 hour. So we're going to say Barbie's portion plus Ken's portion is 1/2 of the whole job. So I don't need to use the calculator here. I know that the least common denominator is 6x. I feel like I probably don't need to do the work for you guys on that one. Okay, number 8 is without question the most difficult problem on the worksheet, like without question. And it's so difficult, it doesn't even belong on this worksheet, except that it does because you guys are all mathematically capable of doing the problem. It is just funny because the whole worksheet is one level of difficulty and number 8 just like blows it out of the water. So we've got Huck and Tom. So it says if Huck painted the fence alone, it would take him 1 more hour than it takes Tom. And then we know what they do together. So together it's 20 hours, so 1/20. Okay. So if Huck painted the fence alone, it would take him 1 more hour than it takes Tom. So this is where I kind of use that strategy that I talked about in the notes, where I said that if I'm trying to figure out with the variable, like with this one, when Marco was twice as fast as Cliff, when I was figuring out who gets the 2, I kind of like wrote down numbers and then I would figure out who gets the variable and who gets like 2 times the variable. I'm going to do the same thing here. So let's say with Huck, I'm just going to use the same number I used before. Let's say Huck, 20 isn't the problem. I'm going to say Huck takes 15 hours to do the fence. It would take him 1 more hour than it takes Tom. So that would mean it would take Tom only 14 hours if we were to just make up random numbers for them for this problem. So that would mean that if we're putting variables in here, that for Huck would be the one who gets the 1 more. So Huck would be x plus 1, and Tom would be just x. Tom takes x hours, Huck takes x plus 1, because it takes him 1 more hour. And maybe that was obvious to you. That was probably obvious to me too. I think it's this one, the wording of this one, that messes me up a little bit more. Okay. So we have this situation. I'm going to go ahead and write out the equation. So I've got 1 over x plus 1 plus 1 over x equals 1 over 20. And my least common denominator, I cannot use a calculator to help me this time because it's not really the numbers that are making this a little bit more complicated. It's the variables. So for my least common denominator, I for sure need the 20. And I do need the x, but I also need the x plus 1. And this is kind of what makes this a more complicated problem, is because the least common denominator is more complicated. So I'm going to be multiplying by 20x times x plus 1. And I'll go ahead and multiply each of the terms by that. So if I look at the first term, the x plus 1's cancel, and I'm left with 20x. If I look at the second term, the x cancels with the x, and I'm left with the 20 and the x plus 1. So I can take the 20 and I can distribute it. So I get 20x plus 20. And then if I look over here on the other side of the equal sign, the 20 and the 20 cancel, and I'm left with an x times an x plus 1. And I can distribute the x, and I get x squared plus x. And this is what makes the problem more difficult. Again, like I said, the problem's not crazy. It's not insane for Math 3. It just has an x squared in the answer, which means that this is a quadratic. And it's not going to stop being a quadratic. So we're not going to be able to solve it by just getting x alone like all the other problems that we've done. This is a problem where we're going to have to either factor it or use the quadratic formula. So to be able to use those methods, I have to make the problem equal 0, and I like to have the x squared term be positive because it makes it easier to factor. Well, it makes it possible to factor, but it makes the problem easier. And so you need that if you're factoring, you need that if you're doing the quadratic formula. So I'm going to go ahead and combine these like terms. This is 40x plus 20. And now that I've combined those like terms, I'm going to go ahead and move them over to the other side. Okay, so this has completely zeroed out. And now I am left with the quadratic x squared minus 39x minus 20. X squared minus 39x minus 20. And if you look at this problem, there's nothing that's going to multiply to negative 20 that's going to add to negative 39. So this problem is not a problem that can be factored. This is a quadratic formula problem, which is the part of this that just seems to not really fit this worksheet. All the rest of these are pretty easily solved. Doing the quadratic formula out of nowhere is kind of wild. Okay, so we're going to go ahead and do the quadratic formula. I'm running out of space, so I'm going to write it down up here. X equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. Okay, so my a is 1, my b is negative 39, my c is negative 20. All right, so I've got negative b, so negative of negative 39, plus or minus the square root of b squared, so negative 39 squared, minus 4 times the a value times the c value, oh gosh, all divided by 2 times a. Okay, negative, negative, that makes a positive. So 39 plus minus the square root of something, all divided by 2. And I'm going to figure out what my discriminant is to put it underneath my square root. So I've got negative 39 squared minus 4 times 1 times negative 20, 1,601. Okay, and now I'm ready to type this in. I'm going to have two solutions, and it's either going to be in a situation where they both work in the problem or where one of them does not make sense. So to type this all in at once, I'm going to put a fraction on the screen. So I'm going to do alpha y equals to get the fraction up there. 39 plus square root 1601 over 2. So my first answer is 39.506. I'm going to get my answer back up here, and I'm going to do the second one. negative 0.506. Okay, so if I go back to the context of the problem, I'm solving for x. Remember, x is how many hours Tom took. Huck is x plus 1. So the negative answer doesn't make sense. That's a period of time that can't be negative. Okay, so Tom took 39.506 hours to paint the fence alone. Huck is going to take 1 more hour than that. So we just did the quadratic formula. We did all this work to get this answer. And if you don't add 1 to it, you're going to get the answer wrong. So Huck took 40.506 hours. And that's because for Huck, it was x plus 1. Whew. It's a wild problem. Okay. Number 10, if you're struggling with number 10, look back at the notes. It's exactly like the example with Marco and Cliff. Mickey takes twice as long to wash the dishes as Minnie. Marco can build a laptop twice as fast as Cliff. Okay, it's not exactly the same, but it's a similar idea. So I talk about how to do one like that in the notes.